Yep. Thanks for letting me talk. So before I get into the main topic, I would like to thank my team that we were thinking together about this project. It was a fun experience, and we're a multidisciplinary team, and I guess we learned a lot. So the topic is the end of fossil fuels. This is in some way a little bit a broadening of the topic before. So we have the same elephant in the room that we wanted to address, and that is the impact of what fossil fuels does to the world. And so you can see here our big idea. If you write proposals, let's say you write your $400,000 proposal, you always have to say in the beginning, how are you saving the world? If you don't save it, you probably don't get any money. So even though it may be a stretch, so here we're really trying to save the world for future generations through the preventing of the emission of further greenhouse gases, in particular carbon dioxide. And so this is a problem that is known for a long time. I have here this Popular Mechanics article, if you want to read it. It already talks about CO2 making an effective blanket for the Earth to raise its temperature. And then it says this effect may be considerable in a few centuries, but we're now 100 years later, and it's really urgent. We are not the only ones, of course, in our group that think this is urgent. There are many, many other people that think the same thing. And so this is why there are White House reports. Department of Energy has reports about decarbonizing the energy production. And the goal is by about 2050. This is with a climate need set date. We are having about the same aspiration for this project here. And so if other people are already talking about it, why are we talking about it too? This is because we are passionate about that. We think we have overstepped our boundaries and treated the planet without the regard for consequences. And scientists have long raised alarm, but failed to motivate decision makers. So this is why we're pushing here again for the same thing, and in some style of moonshot program. So this is a really big program. And we need everything to work together that this workshop is about: accelerate clean energy innovations, increase climate change resilience, and promote sustainable practices. If we can actually reach the broad goal, this has a lot of positive impacts. Of course, dramatic reduction in carbon emissions, but that leads to a significant improvement in the quality of life, health, and the environment. It leads to the creation of green jobs, and independent of from oil and gas, an increased geopolitical stability that goes with it. Localized energy production reduces transportation costs and produces local jobs and local resilience. So what do we have to do to get there? We have to, so there's a multi-pronged approach, of course, and each of these challenges has many, many, many different facets. Reduce energy consumption is one, and then increase energy efficiency that goes with it, electrify what can be electrified, and for everything that you cannot electrify, you have to develop renewables, biofuels, hydrogen, methanol. And that, by the way, doesn't call for actually getting rid of plastics. You can have, after this, the same amount of plastics and iPhones and Sharpies and so on. You just make the plastic out of renewable sources. And of course, we have to manage the transition to a carbon-free system. Okay, so this is an ambitious goal, and it requires many, many levels to work together. So we need many multidisciplinary teams out of scientists, engineers, social scientists, industry, and so on. The funding agencies are also called to not just be within a division, so multiple divisions have to work together, each doing their time. And again, a timeline would be 5 years to get it going, 10 years until you see leaking through society, and 25 years, about 2050 should be the goal. And the methodology, at least that's the part of the methodology that we think is a little bit math related. We have to recognize there are various scales of planning, project, tactical, operational, strategic, on lots of different scales. A variety of different stakeholders and users are involved. We have many different sources of uncertainty and risk that math is very good at managing, and we need to integrate different tools and methods. So why NSF and why DMS? So that's the part, it's a huge project. That's the part that then goes back to DMS, is because mathematical models, data analysis, network science, machine learning, and high performance of computing are key to achieve this. We need all that. I'm just giving you one example, which is a recent advance in the incorporation of observational data and high-resolution simulations for subsystems such as Earth system models to improve climate projections. But of course, we need simulations and that on many different levels, making green energy producing, the chemical processes that involve the batteries, the energy storage, the new materials that we need to do that, the incorporation on the next level. We need a smart grid that knows how to work with transient energy production, and so on and so on. And because of time, I'm running out. I want to summarize the conclusions with a quote from The Economist that said, the Stone Age didn't run out because of a lack of stones, and the oil age will run out even before we run out of oil. And with that, I would like to thank you for your attention.